All right, here we go, guys. I'm gonna go over the practice test, chapter 8. There are 20 problems in this practice test, and I'm just gonna go over 10 of them. I'll go over the odd problems. So hopefully, by doing the odd problems, I can use your note and use what I give you here so that you can do the rest of it, because what you're going to see on Monday is going to be all the problems that are coming from the practice test. All right. Okay, number 1. Say write the product. So make sure you read the instruction carefully. Say write the product using exponents. So they are not asking you to evaluate. So don't take negative 15 times negative 15 times negative 15 and trying to figure out what that answer is. That's not what they're looking for. They only ask you to write it as a product using exponent. So negative 15 times negative 15 times negative 15, you multiply negative 15 itself by 3 times, right? 3 times. So it's negative 15 to the third power. So that would be number 1. Okay. Number 2, now it says evaluate the expression. So when you evaluate, make sure you follow the order of operations. Okay. I'll see there's an exponent right there. So the first thing I need to do is I need to do the exponent, and then I have to divide before I'll add. So again, exponent first, and then you divide, and then you add. Okay. So follow the order of operation. Okay, so you're going to leave the 10 alone for now, plus 3 to the third power. 3 to the third power means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So again, 3 to the third power is going to give you 27. So that's where the 27 came from. And then divided by 9. Okay. And then again, you have to divide first before you add. So 27 divided by 9 is going to give you 3. So that's going to become 10 plus 3. And 10 plus 3 is going to give me 13. So the answer to number 3 is 13. Okay. So remember, when you do this on the test, you need to show all this workout. Okay. I am not interested just in the answer. Okay, you need to. I can tell you what, most likely, if you give me the answer, is wrong if you don't do the workout. Because, like I said, I myself, sometimes I have to do the problem out before I get to the answer. So there's no reason that you only give me the answer without the work. Okay, simplify the expression. It's asking you to simplify. Again, it's not asking you to evaluate, asking you to simplify. Okay, 9 to the 10 power times 9. Okay, well, think about 9 is the same thing with 9 to the first power. Okay, you don't have to write the 1 there if you don't want to, but 9 is the same thing with 9 to the first. So now I need to simplify and write my answer as a power. So 9 to the 10 times 9 to the first. Okay, let's go to the rule. Let's open up your notebook. Go back to the rules, or the exponent rules, or the property that we talk about. Same base. When you multiply, you add the exponent. So you take 10 plus 1 is going to give you 11. So that is the answer to number 5. Okay. So far, so good. Alright, number 7. Let's go over here to number 7. Negative 3.5 to the 13 to the 15 powers times negative 3.5 to the second power, and then divided by negative 3.5 to the 9th power. So the good thing here is, you can see they all have the same base. The base is negative 3.5, negative 3.5, negative 3.5. I see there's a product of a power rule. I also see there's a quotient rule. So whatever rule you decide to do first, just as long as you stick to the rule. So what I'm going to do is I'm going to go ahead and use the product rule first. I'm going to take negative 3.5. Again, the negative 3.5 is inside the parentheses. Very important that the negative is inside the parentheses. So you got negative 3.5 to the 13 times negative 3.5 to the second. So same base, when you multiply, you add the exponent. So you take 13 plus 2, and that's going to give me 15. Divided by negative 3.5 to the 9 power. Again, the negatives inside the parentheses. Negative 3.5 to the 9 power. And then from here, I can go ahead and apply the quotient rule. All right, when you divide same base, you can go ahead and subtract the exponent. So my base is still negative 3.5. All right. And then I'm going to subtract my exponent. So the exponent of the numerator, subtract the exponent of the denominator. So you take 15 minus 9. And that's going to give me 6. And you're done with this. Do not flip this number because you see there's a negative there. There's nothing wrong with having a negative as a base number. Have a base as a negative number. There's nothing wrong with it. Some of you guys confuse, I'm going to go ahead and flip this number because I see a negative. You only do that if the exponent is a negative. You only do that if the exponent is a negative. That's when you use the negative exponent rule, where you have to take the reciprocal of the base and then you switch the exponent from negative to positive. But in this problem number 7, your exponent is positive 6. So please do not go and take the reciprocal of the negative 3.5 because there's a negative in front of the 3.5. All right, let's go to number 9. Round the numbers. Round the number. So this say very specific. It say round it first. You have to round the number and then write the result as a product of a single digit and a power of 10. Okay, so it's 2 things you have to do. Round a number and then write the result as a product of a single digit and a power of 10. Okay, so 1, 2, 3, 1, 2, 3, that's 6 number. 1, 2, 3, that's 9. So this number is what? 4 billion, right? 4,610,426,970. Okay, that's 9 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 4,610,428,970. Okay, so this here I'm gonna round this to 5 billion. Okay, I'm gonna round this up to 5 billion because of the 610 million. So I'm gonna round that up to 5 billion. 1, 2, 3. 1, 2, 3. And then 1, 2, 3. Again, that's 5 billion. So I round the number up to 5 billion, and then from there, my single digit is going to be 5. And I want you to turn that into a single digit and a power of 10. So multiply by 10. And again, like earlier I said, there should be 9 zeros in billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my exponent is going to be 5 times 10 to the 10th power. 5 times 10 to the 9th power. All right. Again, let's go back and count. 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth, 10 to the sixth, 10 to the seventh, 10 to the eighth, 10 to the 9th. So that's 10 to the 9th power. That is number 9. Number 11, write the number in standard form. So here you have a number that is in scientific notation. They want you to turn this number into standard form. So 10 to the 7, well, 10 to the 6 is a million, so 10 to the 7 is going to be 10 million, right? Or you can think of, 3, 7, 0. So you're going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3. So that right there is 30 million. 30 million. 70. 10, 20, 30, 40, 50, 60, 70. So that's 10 million. And 10 million times 3 is 30 million. So the answer again is 30 million. That's how you write that in standard form. All right. This one say evaluate and then write the answer in scientific notations. This is adding and subtracting and multiplying, dividing scientific notations right here. Okay, so the first thing when you add and subtract, check to make sure you have the same exponent. So 10 to the 7, 10 to the 7, you're good to go. Now all you have to do is take 7.8 plus 9.9. 7.8 plus 9.9. Okay, well 7.8 plus 9.9 is going to give me 17.7. 17.7. If you will need help, you can use a calculator for that. But you should be able to do this on top of your head. 8 plus 9 is 7, remain 1. 7 plus 9 is going to be 16. 16 and 1 is 17. So it's 17.7 times 10 to the 7 power. Remember, this is my common factor right there. Okay, I don't have much time left to write everything out for you guys, but definitely check your note over. 10 to the 7 is my common factor. So I'm just going to add the 7.8 to 9.9 times 10 to the 7. Okay, but we're not done yet though, because this right here is not in standard form yet. I'm sorry, it's not in standard form of the scientific notation because of the 17.7. So I'm going to go right over here. 17.7 times 10 to the 7. Okay, well I have to, this is more than 10, so I'm going to move the decimal place to the left 1. So it's going to be 1.77. Okay, I'm going to move in the decimal place to the left 1, then my exponent is going to go up by 1. Okay, I hope I don't need to be explaining that to you, but it's 17.7 times 10 to the first power, that's going to be 1.77. 1.77 times 10 to the first is the same thing with 17.7. And 10 to the first times 10 to the 7 is 10 to the 8. So that's where the 8 came from. Or you can think of that, just move the decimal place to the left once, then this guy is going to go up by 1. All right. Number 17. Are these two numbers the same? You have to explain. Well, let's see that it's the same or not before we explain. But before we do anything, I know that there is a power to a power rule here. So let's do that out and see what happened. Power to a power. So I say x right there. Everything in here raised to the third power. So it's going to be x to the third. And then y squared raised to the third power is going to be y to the 6. Remember, you multiply, right? 1 times 3 is 3. 2 times 3 is 6. Are they the same? Well, let's see. X squared and then y to the 6. Are they the same? They are not. They're not the same. And I'll let you guys explain why. Again, I just apply the power to power rule and they are not the same. So that's one way to explain it for you guys. Okay? All right. It's not the same. It is not the same. All right. Number 19. There are about 10,000 taste buds on a human tongue. Write this number in scientific notations. Okay, that's pretty quick. 10,000. Well, it's good to know that we have 10,000 taste buds on our tongue. That's new to me. Okay, well, you got 10, 20, 30, 40. So it's going to be 1 times 10 to the 4th, and you are done. Okay, 1 times 10 to the 4th power. Does that make sense? Right? 10,000. Again, your single digit is 1, and there's 40, 10 to the 4th, and that's number 19. Okay, I think number 18 definitely is a good problem because now we have to review back to a linear function. Remember, it is y equal mx plus b. Recall y equal mx plus b. Okay, your slope here is gonna be the weight of per scoop. All right, so you can, that's a hint.